Hey, thanks for watching. So today I'm going to be doing something a little different, working on a capital allocation manager. The point of this is when you're live betting, a good strategy is to hold money on both teams, so play the swings in the game. This is mainly the thing I'm interested in using to get an edge. I'll just give a quick example here. So let's go to this game and get the odds, the line history. Okay, so you see at the start of this, okay, this would have been last week. So started plus 225 on, on Arizona, minus 265 on K-State. Then we had the line move, so it's moved slightly for Arizona. So if you could have bet this 225 for Arizona, you could now bet. Okay. Well, this isn't an example of it, but use this one up here if you had bet plus 240 on Arizona. Then it swings to Arizona here. That's still not good enough to cover. Anyway, long story short, you get swings in the spread that allow you to cover your risk. And so when you're doing that, you want to keep adding bets, keep leveraging up, but you want a way to manage it. How I typically manage it is like this. So this is for Trump and Kamala. So I just have an entry for how much I'm risking, how much I could potentially win on Trump, and this I have as F because that's what I'm considering free money. I have $24.50 that I could put on Trump. If I put that on Trump, then I'm still not risking anything on Trump. And the goal would be, so I put this at about even money. The goal would be that it swings, Trump becomes a significant underdog, in which case then, say Trump is like plus 200, then we could say that if we bet $24.50 here, then our risk is still nothing, but we're winning $49. And so 49 minus 25, so that means we have 24 free to bet on Harris with no risk. And so in this sort of scenario, where we have a swing in the odds, if you're holding the right side, then you could capitalize on this by eliminating any risk that you're holding. The problem with this is that if you keep placing bets throughout the day, then it's hard to keep track of the risk you're holding, and it gets exponentially harder as you add more bets. So I'm working on coding this visualizer, which should allow you to add bets. Or not visualizer. This is a tracker. Ultimately, I'd like to add a GUI to it so that you can do this all with an app. Okay, so, and I'm in the middle of this. I just have to remember where I'm at. I'm gonna make myself a coffee real quick. Okay, so make that a little smaller. I'm gonna pull up this so that I don't miss any chats. Hi, thanks for watching my stream. Okay. There. This here. Hide that. Hide that. Oh. Whatever. Okay, so minimize that whole thing. All right, so where are we at? Let's open this here. Already did all of that stuff. Okay. Now, what do we want to do? Add bets to an event, and then we want to do two things. We want to automatically calculate risk reward on that event, and then calculate new odds that are worth taking to increase our advantage. So we want to know where we're sitting at, and then we also want to know what is a swing that's such that we want to take a bet on it. If it swings, do we want to take this bet or not? It's gonna be strong coffee. Okay. So in the event, we want to update the odds. For an option, we don't want to update the odds, we just want to do that. Okay, so when we initialize it, okay. Now, let's just add a function for updating the odds. Okay, so event update odds. For option odds in zip. Okay, so zip together a list of option 1. And then the odds, so option 1 odds, option 2 odds, option dot update odds. Okay, so if there's new odds, we can update them. And then we could say for option in options. Okay. Okay, so for each option, okay, and self.prob is equal to okay. So then each option has some probability associated with it. Okay, then for each option, we want to calculate the expected value of the option. Self.ev. Wonder. Oh, that's fine. Okay, so expected value is self.prob times risk minus self.prob times okay, so the probability that happens times payout minus self.prob. Oh, okay, the yeah. Okay, minus 1 minus self.prob. So the probability that it loses times self.risk, self.payout. Okay. Now for that option.calc.ev. Okay, now let's go test this. So alright, now we're gonna say let's make an event. Option 1 is just do the same thing. So Rams versus Lions, and the fee, let's say it's a 5% fee. And then we're gonna say e.place bet. So first we're gonna place a bet on the Rams. The Rams are plus 200. Option name Rams plus 200. And then the odds, odds are plus 200. Alright, so let's put $10 on the Rams plus 200. Now, e.calc ev option object has no attribute prob. Calc ev Okay, then we could just say self.update odds option 1 odds option 2 odds. Okay. And then, so let's just say it's starting at Rams plus 200, Lions minus 180. And then we're going to say e.placebet. So let's, I don't know. Okay, let's place a bet on the Rams. The odds are plus 190, and we're going to risk $10. Okay, now if we place a bet on the Lions and it's minus 150, then we should end up with positive EV. Okay, and then let's update odds to be plus 130 minus 150. And then e.calc EV. And then what's EV? More negative. Option 1, option 2. Okay, so what if we do E dot option 1 dot EV E dot option 2 dot EV. Okay, so how do we get option 2 dot odds, option E dot option 2 dot bets of 0 dot risk so self.prob times self.payout. Just trying to figure it out. So option 1.ev. Well, that should be positive expected value, right? Self.payout equals, so sum the bet payout, sum the risks, and then EV equals the probability of it winning times the payout minus probability of it losing, which is just 1 minus the winning probability, times what we're risking. I'm just trying to figure it out because the expected value should be positive. So, all right, let's say O is equal to option. The name will be Rams, and fee is 0.05. O dot place. All right, so we're gonna place a bet. All right, O dot all right. Now first, let's say we're gonna place a bet. And the bet is plus 200. Bet is 100, so we're saying it's just a toss-up. And we're gonna risk $10. Calc EV option update odds. Okay. Update odds was we just bet it at 100, so we're updating the odds to be 100. Now we calc EV. Now we say, what's the expected value? Now if the odds swing to 150, the expected value goes down? Oh, because they become a bigger underdog. Okay, that makes sense. So now, okay, so we bet on them at 100. Now they're becoming more favored. Minus 150. Okay, so expected value. So what do you have to do to get expected value to be positive? Update odd. That makes it positive. Okay, so next, let's answer this. What is the break-even point of expected value? Okay, I'll be right back. I'm going to the bathroom. Okay, so now we want to figure out what's the break-even point for expected value? So minus 200, so if it swings, okay, so it's really small, minus 210. So the expected value doesn't go positive. So really, we want to get the difference between the EVs. Right? You do the expected value of option 1 minus the expected value of option 2. Yeah. Okay, then self.ev I should write this out on a piece of paper. So we want to figure out option 1 and 2. How do we... I need a pen. Alright, so how do we get the EV? So we're doing so expected value was probability of outcome. So probability, so we have oh, hi Ivy. Sign into chat. Oops. Hello. I don't know. Chat. Oh, no, I can't see the chat. Oh, well. Hi. I'm building a risk manager for my betting. So, we want to figure out how do we calculate expected value. Alright, so prob win times probability of bet 1 winning times bet 1 risk so the probability of it winning times whatever we stand to gain minus probability of bet 1 losing times bet 1 risk. Okay, and then the bet 2 is related to bet 1, because if bet 1 wins, bet 2 loses. Okay, so minus, that's just minus, so that's the EV. So then we want minus, yeah, we're just getting the difference of the EVs. So if we do, E dot option 1 all right, so option 2 minus option 1 is positive. Option 1 minus option 2 is negative. Oh, but those are the same values. Okay, now we're on to something. Woof. So that must be the real EV, and we must be trying to get that positive. So self.EV, self.team1 EV, self.EV1 is equal to self.option one EV minus self.option 2 EV. Oh, but they're always going to be different. One of those is always going to be negative. One of those is always going to be negative no matter what. So what if we could turn both expected values positive? There must be, okay, so if we do the combined expected value, probability of bet 1 win minus probability of bet 2 win minus probability of bet 2 loss. So I guess we just, the combined EV, we don't want to we want to get them together, I guess. So if we want to get EV for this, we say, okay, get the EV for each option. Now, team option 1 wins. All right, so if option 1 wins, then option 1 profit is equal to self.option 1 dot payout minus self.option 2 dot risk. equal to self dot option 2 dot payout minus self dot option 1 dot risk. And then we could say self dot EV is equal to update odds. So self dot option 1 dot prob. So whatever the probability is that option 1 wins times option 1 payout minus plus probability option 2 wins times option 2 payout minus probability. All right, let's change this to self dot win prob is equal to prob self dot lose. Make that self dot prob. Self dot lose prob is equal to 1 minus self dot win prob. Oh. Forget about that. So they'll be offset. So minus 1 minus self dot option 2 dot prob, because that will be a lower probability than 1 minus self dot option 1 dot prob. And then multiply that. Okay, so minus, all right, so option 1 payout. Oh, so probability that option 1 wins plus probability times option 1 payout plus probability that option 2 wins times option 2 payout minus probability that option 1 loses times option 1 risk back to this. Okay, focus. We have it just in terms of 1 or 2. Probability that option 1 wins times the total payout for option 1. Okay, so then we could say option 1 risk is equal to self dot option 1 risk minus self dot option 2 dot payout. Right, because whatever we're risking on option 1 isn't really a risk because we also win the payout for option 2. And then option 2 risk is equal to self dot option 2 dot risk minus self dot option 2 dot payout. Okay, so then if we're only betting on option 2, then option 1 payout is a negative. Oh. So then we just have to do okay. So if option 1 wins, so you want to do the probability option 1 wins times option 1 payout. Okay, so self dot prob self dot option 2 dot prob. If we do 1 minus, then we get the probability that option 2 loses, which is the probability that option 1 wins, the lower probability, which is what we want to be conservative. So probability option 1 wins times option 1 payout plus probability that option 2 wins, so same thing. Same thing as before, but opposite, times option 2 payout. That's all we need. All right, now let's see if that makes sense. From risk management, import everything. Okay, now we say E is an event, and all right, let's just use the same example we've been doing last week. Sunday night game, let's do Rams Lions. The fee at our hypothetical sportsbook is 5%, and it's opening with plus 150 on the Rams and minus 130 on the Lions. Okay. Now we're gonna place bet on the Rams. And it's at plus 150. And we're gonna risk $10. Okay, now let's see. If we calculate the expected value. Oh yeah. Lowercase. Okay. So if we just take that, then we get a negative expected value. Now, let's say that it swings. And the Lions now, I can bet on them at minus 110. And we put $10 down. And then let's update odds. And the new odds are Rams plus 130, Lions minus 110. Calculate the EV. Oh, and it's even worse now? Option 1 payout equals self.option1.payout minus self.option2.risk. E dot option 1 dot EV, is that positive now? No. Dot odds. So the odds of the bet are plus 150. Current odds are plus 130. So that should move in our favor. So $10 at Rams plus 150. Update odds. All right, let's go back to focusing just on what do we want to do. Football is equal to square root negative football x pi. That's a very good equation. I'll try to implement it. So why is our EV so low? Expected value is 1 minus option 2 dot prob. So the odds of it happening are minus 130, which gives it a 56% chance. Which would mean we have 0.46. That, just make it E. Option 1 dot payout. So what's the payout? The payout for a single bet is so if we bet $10 on so-and-so minus 130, that's our payout. All right, I think I'm going to end this here. Thanks for watching. I didn't really get much anywhere. Hopefully this weekend we'll be able to build this up to a point where we could use it on Sunday. Yes, I can see the little hearts, but I don't watch that closely, so yeah, thank you to my lone viewer. Goodbye, Ivy.